Now, it is given equation of tangent to the curve. So, equation of the curve is given. Equation of the curve is y square equal to ax cube plus b. Now, point of contact is given. Point of contact P as 2, 3. Now, equation of tangent is y equal to 4x minus 5. And we have to find the value of an. Now, to find the equation of tangent, we have to find a slope and then the equation of tangent. So, for finding slope, we have to take it as equation 1. So, on differentiating equation 1 with respect to x, we get 2y dx of y equal to 3ax squared. Now from this we get dx of y equal to 3ax squared by 2y. Now from this we get dx of y at 2, 3 equal to 3a into square by 2 into 3. So this gives us equal to 2a as a slope. Therefore, equation of tangent y minus y1 equal to slope into x minus x1. Now y minus 3 equal to 2ax minus 4a. So this is the equation of tangent which I got. Now this should be identical with, if we simplify this one, 2ax minus 4a plus 3. Now this should be identical with equation 2. So we mark this on equation 3. Now 2 and 3 must be identical. So if 2 and 3 are identical, we can write on comparing 2 and 3. On comparing 2 and 3, we get 2a by 4 equal to 1 by 1 equal to 4a minus 3 by 5. Now we have adjusted the sign here. So a is coming around 2 and b is coming as minus 7. So equation of the curve x square plus 6y equal to 7. We mark this as equation 1. And equation of the other curve y equal to x cube. Now we have to find the angle between the two curves. So for finding the angle between the two curves, at first we need the point of contact. Yes, here we need the point of intersection. At first we need the point of intersection. So let P x1, y1 be the point of intersection. Be the point of intersection. So we can write x1 square plus 6y1 equal to 7 and y1 equal to x1 cube. So x1 square plus 6x1 cube equal to 7. Now from this, if we simplify, we can easily understand x1 equal to 1 will satisfy. Here we can easily understand x1 equal to 1 will satisfy the above equation. Now when x1 equal to 1, y1 equal to also 1. So here what we say that y1 equal to also 1 from the above equation from this one. So the one of the point of intersection which we have got, point of intersection is 1 comma 1. Now we have to find the slope of the curve at those points. So if we find the slope of the curve, what we get? On differentiating equation 1, on differentiating equation 1, we get 2x plus 6 ddx of y equal to 0. So ddx of y equal to minus x by 3. Therefore, ddx of y at the point of contact 1 comma 1 equal to minus 1 by 3. Again, on differentiating equation 2, we get ddx of y equal to 3x. Now we have to find at the point of 1 comma 1. So we get ddx of y at 1 comma 1 as slope as 3. So this will mark as equation 4. Now on multiplying equation 3 and 4, basically we are trying to find the product of the slopes. We get product of slopes equal to minus 1. Therefore, curves are orthogonal. That is, angle between the curves at their point of intersection is 90 degrees. See, equation of hyperbola given. Equation of hyperbola. X square minus y square equal to a square. We mark it as equation 1. Equation of circle. X square plus y square equal to root 2a square. This is marked as equation. Now, at first, we understand that if we represent this in the graph, how does it look like? So take a Cartesian plane where we represent this. At first, we represent the hyperbola. So we have a hyperbola which is a square minus y square equal to a square. So the vertex we can see is a comma 0 and a prime is minus a comma 0. We take here a circle whose equation is given by square plus y square equal to 2a square. So you can see here the radius which will get in this case. We can mark this point. This is the point A, which has been already been shown. And for the circle, we take the radius as radius point. So you can understand this OR1 will be the radius. So here R1, which will take will be 2 to the power of 1 by 4 a comma 0. And here also we can take the point which is R2, which will be minus 2 to the power of 1 by 4 a comma 0. So we got R1, we got here R2. Now we can understand here there are 4 points of intersection. 4 points of intersection is possible here. So at first we find the point of intersection because to find the angle between these two curves, we need this point of intersection. So to find the point of intersections, we take x square minus y square equal to a square and x square plus y square equal to 2a square. Now on adding these two equations, we get 2x square, just we are adding this, equal to a square comma root 2 plus 1. And from this we get that x can have the two values here. There is plus minus a under root of root 2 plus 1 by 2. Now substituting this value of x in equation 1 or 2, anyone we can substitute. On substituting the value of x in 1, we get y equal plus minus a in root 2 minus 1 by 2. So you got here the values of x as well as values of y, and we can understand the 4 points are possible. So we take here the 4 points as P1, which is the first quadrant. Second quadrant point will take us P2, third quadrant point will take us P3, and fourth quadrant point will take us P4. And we can understand that P1 will be when both x and y positive, P2 when x negative, y positive, P3 when both negative, and P4 when x positive and y negative. So this is what we get. Now we can find the angle at any point of intersection. It is not mandatory that we have to find here or here or here. At first we find here at the point P1. We can find all the 4 points. So at first we find, since they have told in the question that find the angle between the circle and the hyperbola, we take out first at the point P1. Very simultaneously you can verify at P2, P3, P4 also. But to find the angle between the two curves, we need the slope of the tangent at this point P1 for both the curves. So we differentiate equation 1, we differentiate equation 2, and check what we get. So on differentiating equation 1, we get dx of y as x by 1, and on differentiating equation 2, we get dx of y as minus x by 1. Almost the same result, just the variation in the sign, nothing else. Now at P1, we try to find the angle at P1. At P1, the point is a root over root 2 plus 1 by 2, comma, a root over root 2 minus 1 by 2. So at first we find the slope for the hyperbola. That is, what is the, if we draw a tangent, there are two tangents possible. At hyperbola, at first if we draw, then it is this is the tangent, drawn the hyperbola, and we name it as T1. So to find the slope at the point P1 for the hyperbola, that is dx of y at P1 equal to, if we substitute here the value, a into root over plus root 2 plus 1 by 2, with the value of x and value of y, we get a into root over root 2 minus 1 by 2. Now this we take as m1, which is the slope of the tangent T1, you can say. Slope of tangent T1, which is drawn to the hyperbola. Now if we simplify this one, we get here m1 as root over root 2 plus 1 by root 2 minus 1. Now this can be further simplified and can be written as plus root 2 plus 1, because we can rationalize the numerator denominator and we get root 2 plus 1. Now as we have got the slope for this hyperbola, similarly you can find a slope for circle also, because at the point slope when the tangent is drawn at the point P1 to the circle. This was the tangent, this is which we have found out. This is slope of the tangent drawn to the hyperbola at the point P1. Now we try to find slope of the tangent drawn to the circle at the point P1. That we consider as this, which we name as T2. Slope of the tangent drawn on the circle at P1. Now for that, dx of y at P1, that will be minus a root under of root 2 plus 1 by 2 whole divided by a root under of root 2 minus 1 by 2. Now this will be m2, we will consider, which is the slope of the tangent T2. Slope of tangent T2. Now if we simplify this, m minus root 2 plus 1. So everything is same, just to get here minus root 2 plus 1. Now here we got m1, we got m2 also. This is m1 and same 2. So now we can find the angle between these two tangents. Obviously, we consider at first the acute angle, so we consider theta with the acute angle. Let theta be the acute angle. Acute angle at P1. between the curves, between the given curves. That is equation 1, hyperbola, and equation 2, circle. So angle between the curves is same as the angle between the tangents. At so we can write that therefore tan theta equal to mod of m1 minus m by 1 plus m1 m. We substitute here the result, that is root 2 plus 1 plus root 2 plus 1 whole divided by 1 minus root 2 plus 1 whole square. Now this gives us 2 times root 2 plus 1 divided. Now if we get up in the bracket, this will be 2 plus 1. It's minus 2, minus 2, minus 2. So you get here minus 2, minus 2. Now here if we take minus common, or we can write here 2 root 2 plus 1 divided by minus 2 common, root 2 plus 1. That gives us 1. And therefore theta equal to 45. So the angle between the two curves at the point P1 is 45. The acute angle obviously is 45. So these two tangents have been drawn, and the acute angle which you'll get as 45. Now this was for only at one point. Similarly, we can find at the other points also. At this point and this point, it is expected to be same because here both positive coordinate, here both negative coordinate. So ultimately, we'll get the same thing. So, or you can say by symmetry of the diagram, we can say that angle between the two tangents at this point, acute angle between the two tangents at this point, and acute angle between the two tangents at this point is same. So you can write it here by symmetry of the diagram. We can clearly conclude that the angle between acute angle between the two curves at P1 and P2 must be same. Now we come to the point P2 at P2. Now here also we try to find the angle between the two curves. So for that, at first we have to find the slope. So we draw a tangent here at this point P2. At first to the hyperbola, and then we'll find the tangent at the circle. This we mark as T3. So slope of the curve, slope of the hyperbola at P equal to slope of tangent at P. Now here it is M3 we mark, which is ddx of y at P. So you know ddx of y here is x by y. So at P2 we have minus root 2 plus 1 by 2 under root whole divided by a into root over of root 2 minus 1 by 2. So on simplification, we'll get here minus root 2 plus 1 as we have got earlier also. The same type of calculation we have got while finding the slope of the tangent to the curve circle, tangent to the circle at the point P1. So same concept we have got. Now similarly, if we draw another tangent to the circle at the same point, here also you can find the slope. This is T4. So slope of the circle at P2 equal to slope of tangent at P2. So we take slope of the tangent at P2 as M4, which is dx of y at P2 equal to minus of minus 1 into a under root of root 2 plus 1 by whole divided by a root over root 2 minus 1 by 2, which in further simplification gives us root 2 plus 1. Now, let us assume the angle between the two tangents to be theta. Let theta be the acute angle between the curves at. Now we know the angle between the two tangents or between the two lines at a certain point P2 is given by tan theta equal to modulus of M4 minus M3 by 1 plus M4 M3, provided none of the line is perpendicular to axis. And here we can see M3 and M4 by the values that is neither parallel to y-axis or perpendicular to x-axis. So we don't have any problem here. We can apply the formula. Here M4 we know the value which is root 2 plus 1, and here we have minus of minus, so we write plus root 2 plus 1 divided by 1 minus root 2 plus 1 whole square. Now this one simplification gives us 2 into root 2 plus 1 by minus common 2 into root 2 plus 1. Now this gives us 1. Therefore, theta is pi by 4. Therefore, we conclude acute angle between the curves is pi by 4 at all the 4 points of intersection. 4 points of intersection. Equation of the curve. Equation of the curve. X cube minus 3xy square plus 2 equal to 0 as equation 1. We have another equation. So equation of the other curve equation of the other curve y cube minus 3x square y plus 2 equal to 0. Now both these curves definitely intersect at some point. So we take that point of intersection, that is let point of intersection be x1, y1. So both of this point of intersection will satisfy both the equation. So it will satisfy equation of both the curves. Equation of both the curves. So x1 cube minus 3x1 y1 square plus 2 equal to 0, and y1 cube minus 3x1 square into y1 plus 2 equal to 0. Now we know, and we mark this as equation 3. Now we know for both of them we have taken simultaneous equations. Now to find the tangent, find the angle between the two curves, we know we have to find the slope of the curve at the point of contact. So we differentiate equation 1. So on differentiating equation 1, we get gdx of y equal to x square minus y square by 2x1. So on differential equation 1, we have got this one. Now slope of the curve at x1, y1, we have taken as m1 x1 square minus y1 square by twice x1, y1. On differentiating equation 2, we get 2x1 divided by y square minus x square equal to x of 1. Therefore, m2, which is the slope of the curve at x1, y1, is equal to twice x1, y1 by y1 square minus x1 square. Now, m1 into m2, if we perform, we get minus 1. Therefore, angle between the curves is 90. Equation of the curve. Equation of the curve ax square plus by square equals to 1, and equation of the other curve. Equation of the other curve is cx square plus dy square equal to 1. Now here we take the point of contact, point of intersection P x1, y1. Now on differentiating equation 1, on differentiating equation 1 with respect to x, we get gdx of y at x1 y1 equal to minus ax1 by y dy1, and on differentiating the second equation and on differentiating equation 2, we get gdx of y equal to minus cx by dy, and this implies gdx of y at x1 y1 equal to minus cx1 by dy. So this is what we have got as a two equation. Now two steps to check on. Now this one we take as m1 minus ax1 by by1, and m2 we take minus cx1 by dy1. So we have got m1 and we have got m2. Now they intersect at right angle. Since curves are orthogonal, so m1 m2 equal to minus 1. So AC x1 square by BD y1 square equal to minus 1. Now from this we get x1 square by y1 square equal to minus BD by AC. And therefore we get AC x1 square equal to minus BD y1 square. We mark it as equation 3. Now, since this point of contact is lying on the curve, they must satisfy the equation of the curve. Since this one is lying on the curve, they must satisfy the equation of the curve. So from that, what we can write? Since P x1 comma y1 is the point of intersection, so it will satisfy the equation of curves. That is a x1 square plus b y1 square equal to 1, and c x1 square plus d y1 square equal to 1. And this implies a x1 square plus b y1 square equal to c x1 square plus d y1 square. Now from this, a minus c into x1 square equal to minus comma b minus d y1 square. Now, in the previous part we had equation 3, and now we have equation 4. We divide equation 4 by equation 3. We divide equation 4 by equation 3, and we get a minus c by ac equal to b minus d by bd. We get here 1 by c minus 1 by a equal to 1 by d minus 1 by b. So 1 by a minus 1 by b equal to 1 by c minus 1 by d, which is the required condition. Given equation of curve, given equation of curves is ax cube plus by cube equal to 1, which we mark as equation 1. And another equation of the curve is cx cube plus dy cube equal to 1. Now it is said in the question that they cut orthogonally. We have to show when curves cut orthogonally, then the condition AC into B minus D whole to the power of 4 by 3 plus PD into A minus C whole to the power of 4 by 3 equal to 0 is satisfied. So this is our intention to get this condition. Now when the curves cut orthogonally, they cut basically at the point of intersection. Always whenever we find the angle between the two curves, we find at their point of intersection. So here also, at first we consider that there is a point of intersection P. P x1, y1 be the point of intersection. Be the point of intersection of the curves represented in equation 1 and represented in equation 1 and now as it's a point of intersection, so it must satisfy the equation. So since this is a point of intersection, it must satisfy the equation. So this implies that P x1, y1 will satisfy the equation of the curves. This implies A x1 cube plus B y1 cube equal to 1, which we mark as equation 3, and C x1 cube plus D y1 cube equal to 1, which we mark as equation 4. Now, this part is done. Next, they cut orthogonal means product of the slopes at that point of intersection should be -1. Now, to find the slope, at first we have to differentiate this equation, and then we can find the slope of the curve exact at the point of intersection. So, to do that, we differentiate the given equation on differentiate equation 1. We get ddx of 1 will be equal to minus ax square plus by square. Now we're trying to find the slope at the point x1, y1 at the point of intersection. So ddx of y at x1, y1 equal to minus ax1 square plus by1 square. Now this we take as equation 5, and we say that this is our slope for the first curve, and we can write it as m also. We can denote it by some m1. So basically we are denoting this slope only given by equation 5 as m1. Now similarly, we find the slope of the second curve at the point of intersection on differentiating equation 2. So on differentiating equation 2, we get ddx of 1 equal to minus cx square by dy square. Now this implies that ddx of y at x1 y1 equal to minus cx1 square by dy1 square. Now this we denote by m2 and mark as equation 6. Now the first condition is that since the curves are orthogonal, what is the slope will be minus 1. So we write here that since curves are orthogonal, that is the angle between them is 90 degrees. Therefore, product of the slopes, product of the slopes of the curves at the point of intersection, at the point of intersection is minus, which implies m1 into m2 equal to minus 1. Now we know what is m1 and what is m2. So we just substitute the value a x1 square plus b y1 square into minus c x1 square into d y1 square equal to minus 1. Now this gives us x1 to the power of 4 by y1 to the power of 4 equal to minus, because minus into minus cancel out. Here we have a minus sign, so this will be minus bd by s. Now this we mark as equation 7. Now basically we have to eliminate this x and y so that we can get the relation between a, b, c, d, which we need according to the proof. So what we can do, we can solve these two equation, equation 3 and equation 4, to get another equation related to x and y. So if we subtract this equation 4 from equation 3, on subtracting equation 4 from equation 3, we get a minus c into x1 plus b minus d into y1 cube equal to 0. And this gives us x1 cube by y1 cube equal to minus b minus d by a minus c. Now, as we see that in equation 7, we have to the power of 4. So we try to bring it into the power of 4 only. So for that, we can write that x1 by y1 whole to the power of, if we take here to the power of 4 by 3, then only we'll get to the power of 4 on both sides. So we get here, if you take 4 by 3, so 4 means this will be plus, and then you take cube root. So it is b minus d by a minus c whole to the power of 4 by 3. Now this will give us equation 8. Now from 7 and 8, if we just correlate 7 and 8, then the sum is done. So from equation 7 and 8, what we can write, this was from equation 7 we see that it is bd by ac minus bd by ac. So here we write minus bd by ac equal to b minus d whole to the power of 4 by 3 by a minus c whole to the power of 4 by 3. Now we cross multiply and rearrange into bd equal to minus ac into b minus d whole to the power of 4 by 3. So if we rearrange, we get here ac into b minus d whole to the power of 4 by 3 plus BD into A minus C whole to the power of 4 by 3 is equal to 0. It's the required condition. So given equation of the car, given equation of the car, y equal to a plus bx plus cx, which we mark as equation 1. The point where the car meets the y-axis absolutely 0. So if we substitute the point 0, x equal to 0 here, y is becoming a. So we get 0 comma a as a point of contact for the tangent. So therefore, point of contact is 0 comma a. Now it is given the question that at this point equation of tangent is given. So equation of tangent at 0 comma a is 2x plus y equal to 3. So since it's a point of contact, so that means it must satisfy the equation of tangent. Therefore, point of contact must satisfy the equation of tangent. So 2 into 0 plus a equal to 3. This implies a equal to 3. So this is one information you're getting, that a equal to 3. Now, again the slope of the curve at that point, at the point of contact, equal to slope of the tangent at that point. Slope of the curve at 0 comma a equal to slope of tangent at 0 comma a. Obviously, slope of tangent will be same throughout. Now this implies slope of the curve at 0 comma a. So we have to differentiate this ddx of y at 0 comma a. So this is ddx of y at 0 comma a equal to slope of tangent, which is minus 2. Now this gives us, when we differentiate this curve, we get here b plus 2cx, since x is 0, so we get only b. So b gives us minus 2. So we have got the value of a, we have got the value of b. Now it is said, if the normal to the curve at the same point, at this point the normal drawn meets the curve again at the point whose epsilon is 5 by 2. So to find that, at first we have to find the equation of normal. Now here slope of tangent is minus 2 at this point. So from this we can find the slope of the normal. So slope of the normal at 0 comma a is minus 1 by minus 2 half. Therefore, equation of normal is y minus y1 here, which is a equal to half of x minus 0. Now we know the value of A. We have got the value of A, which is 3. So y minus 3 equals to half of x. Is the equation the norm? Now, equation the norm, this normal is meeting the curve again. We can rewrite this as y equal to x by 2 plus 3. Now, this normal is meeting the curve again when the abscissa is 5 by 2. That is when x is equal to 5 by 2 is substituted here. That will correspondingly substitute the equation of the curve also. That is when x equal to 5 by 2, then we can write that 5 by 4 plus 3 equal. Now at that point the ordinate of the curve corresponding to x equal to 5 by 2 will be same. So that is a plus b into 5 by 2 plus c into 5 by 2 whole square. Now from here we substitute the value of a, that is 3. We got the value of b, which is minus 2. So we substitute here minus 2 into 5 by 2 plus c, which we don't know, 25 by 4. So this 3 and this is getting cancelled out, and we get here 5 by 4 equal to minus 5 plus 25c by 4. Now we simplify this one further, and we get 25c by 4 equal to 5 plus 5 by 4, that will be 25 by 4. And this implies that c equals to 1. So thus we got the value of a, b, and c, which is equal to 100. So here we write that therefore required values of a, here a is 3, b equal to minus 2, and c equals to 1.